Now we will look at the erosion operation in detail. The definition of erosion operation is as follows. Imagine that you have two different sets A and B, and the elements of the sets A and B are coordinates points in a 2D plane. So that is the meaning of the notation z square. If you are writing z cube, then you are referring to a point in the 3D space. The erosion of A and B is denoted by A erosion B. So you have to read this symbol, that is the symbol minus within a circle, as erosion. So A erosion B is defined as A erosion B is equal to Z such that the BZ is a subset of A, or the BZ is completely confined inside the set A. So we know the meaning of BZ. We are actually translating the set B into another coordinate Z. If all the points of BZ is within the set capital A, then you can take that Z into my new set. So I will be forming the A erosion B set with all those values of Z. Okay. So in words, the erosion of A by B is the set of all points Z such that B translated by is contained within A. When I discuss an example, you will understand the meaning clearly. Now most of the time the set B will be the structuring element. So we had seen the concept of structuring element the previous video. Now we will look at one example to see what will happen if I do the erosion operation of this set or this object. Whenever I say about object, you have to understand that I am referring to the pixels with a color in it. So this is the object, that is the blue shaded pixels are my object. Then I am eroding that using a structuring element of this shape or a plus sign. In this picture, the intensity values where I have shaded blue is having intensity value 1 and the white one is having intensity value 0. Okay, so similarly you have to take the same convention into the case of structuring element. Now we will see what will happen if I erode this object or this image using this structuring element. Here I have two images, one representing the object A and another one representing the structuring element B. We are going to perform the erosion operation between A and B. Then I will be marking the result on the last image. When you look at this image, you can see that unlike this image, it has got two extra rows and columns in the beginning and the end. This is due to the fact that when you move the structuring element to the very first point of the image A or the object A, there will be some pixels of the structuring element which lies outside the boundary of the image A. So in order to give a valid overlap for the points of the set B, we are giving an extra row and column for the resulting image. Whenever we find the result, we will remove that is not needed for our final result. In order to perform the erosion operation, you have to take the center of the structuring element and you move that to the first pixel of my image. So I will be placing that structuring element over here. So if I mark the intensity with value 1, you can see that lies on my original image like this. So blue shade is having an intensity 1, so I am drawing only those points in this image. Now you can see that the structuring element is not completely confined in the original set A because these 2 points are outside the original image or the original set A. So we cannot take this point as part of our final result. So I will not be taking that point into our final result. Okay. Then in the next step, I will be moving that into the next point. So I will place my structuring element over here. Now also you cannot find that the structuring element B is not completely confined, or BZ, that is B moved to this point, is not completely confined in the set A. So this will not be a part of the final result. And even if you move to this point, there will be no complete overlap. This point no overlap, this point no overlap. Come to this point, and if you place the structuring element over here, then also you cannot see a complete overlap. So you cannot take this point also into my final result. But the first complete overlap comes when you place the structuring element at this location. So the structuring element shape will be something like this. So that indicates that you can take this point into my final result. So I will be shading this point with a red color in order to indicate that that is part of my final result. So this is part of my final result. And if you place the structuring element over this pixel, then there will not be complete overlap. There is no overlap at this point, not at this point, and not at this point, and there will be an overlap if you place the structuring element over this point, and again there will be a complete overlap if you place the structuring element over this pixel, and there will not be any overlap if you place it in this pixel. No overlap here, no overlap at this point, and there will be an overlap at this point. There will be an overlap at this point. No complete overlap if you place it at this point. No overlap at this point, no overlap at this point, and no overlap at this point also. So then these are the pixels that will appear in my final result. So when you look at this object and this bigger object, you can see that the bigger object has got reduced in size, or it has got some erosion. Okay, so that is the result of A eroded with B. Now we had seen the result of erosion of this image with this structuring element. The result would look like this one. So when you compare the original image and the resulting image, you can see that the shape is approximately the same, but it has reduced in size, or the object has become thinner, as well as in terms of morphological image processing, we will say that the image has got eroded. If the object in this image does not have the size of the structuring element, then that particular area in the image will be vanished in the result. So in MATLAB, we can have a function called imerode, which will take two parameters. The first one is the image and second one is the structuring element in order to perform this operation. On the right side, I have shown certain examples of using the merode function, or the result of erosion. So here I have my original image which shows some traces of a PCB. If you erode this image using a square structuring element of size 11 by 11, this is the result. And if you do it using a 15 by 15 square structuring element, this is the result. And if you do the same operation by using a 45 by 45 square structuring element, this would be the result. As you can see that as you increase the size of the structuring element, the thinner part of the image is getting vanished in the result. If the area in the image cannot be confined inside a structuring element, those areas will be vanished. So it will find application where I have to remove noises or unwanted small areas in my image. We can perform the erosion operation. Now I will show the same example using MATLAB by using the imerode function. I am reading an image. I is equal to imread, this one. I will show this image, show I. So this is the image, the same image of a circuit board in binary pixels. Now if I define a structuring element, if you want to define a structuring element, in MATLAB there is a function called strel, the short form of structuring element. If I give, first I need to give the shape. So you can see that there are several different shapes, some ball shape, disc shape, square shape, etc. So I am first using the square shape. Then I will be using the size of the square. So first I will test with size 11. So this, if you want to view the structuring element, the structuring element is a matrix of size 11 by 11. Now in order to perform the erosion operation, I am using the function imerode. So imerode, first I need to give the image itself. So my image is in the variable I, then the structuring element is in the variable SE, and the result is assigned to the variable J. Now if you view the image show J, then you can see the image where a thinner part of my original image is being removed. Now if you come back to the structuring element, instead of 11, if I use 45, Then if I perform the erosion operation, then view the image, then you can see the square only. This is the only part in my image which can be confined inside a 45 by 45 square structuring element. I hope it is clear. Thank you.